Welcome back to this tutorial on programming in C++ for the Arduino IDE. Now, this lesson is about using the basic numeric types of variables, and in previous lessons we've only used one variable type, which has been the int or integer, and we've used it for the value of Q and the value of W. Now, I haven't really gone into any depth as to how that actually works, because once we start to get into the workings of these things, we have to sink down to start to understand bits and bytes, and I've tried to avoid those things in the first few lessons. However, there comes a point where we have to learn these things. And I've brought them all up in one go, so you can have a heart attack in one, immediately. And so today we're going to learn about bits, bytes, integers, longs, and then signed and unsigned versions of our longs and integers. Now at this point, I may as well be speaking in a foreign language to many people. So what I'm going to try and do is break this down into some examples, and we're going to try and visualize things. I'm quite a visual person myself. If you just give me the theory of something, I'm not going to get it. I need to see a bit of a picture. So what we're going to do is look at a few diagrams and different things that I've drawn up, and I'm hoping that as we go through these things you'll get the idea of what I'm talking about. Now, one thing to understand is you probably won't grasp all of this in one go. I certainly didn't. It's something that you need to have the basics of sort of in the back of your mind, but don't forget, in all these things there's always the manual. We can always go and look these things up again, but I'm hoping by the end of this lesson you will have got the basics of numeric variables, and it will help you going forwards in how you program. So I'm going to change the screen over and let's get our first example. Now, I've already started up the IDE and I've saved my basic file. I've already put some information in it because I wanted to make sure that I get this absolutely right. But before I even start the lesson, let's do a quick reminder that we can go to the help. We can click on reference, and when we look under the heading of variables, we can come down to data types, and the data types that we are going to use today, and even some that we're not going to use, are all listed here. And again, if we click on integer as an example, it will give you the range of an integer, and it'll even give you a couple of examples to explain how an integer works and some of the interesting things you can do and some of the things you shouldn't do. So just remember, the reference is your friend. Now, most people know that computers are not particularly clever when it comes to counting. They can only store ones or zeros. So every number that we have on a computer is made up of ones and zeros, and we call it the binary language. And the smallest value is what we call a single bit, and on the Arduino that is called, or in C++, that data type, that variable type, is called a Boolean. I've just called it my Boolean here, but it can only store one of two values. It is either a 0 or a 1, and that is a tiny piece of information. Now, just so you know, when we declare a Boolean or a byte, an integer or an unsigned integer, what happens within the Arduino, within our programming code, is a piece of memory is assigned for the size of the piece of information that we have called our variable. So if we've got a Boolean, my Boolean will point to an address in the memory that can store 1 bit. It can either store a 0 or a 1. When we come down to a byte, it can store 8 bits. And again, so when I declare it a variable type of a byte, it goes out and it finds a parking space big enough for 8 bits. And the reason I'm going to use parking spaces, I'm going to swap over to my other screen, because to try and get our heads around this, we're going to use what I would call my numeric variable digital car park. So up here we have our Boolean, 1 bit, 1 or 0. The next parking spot, if you think of a motorway services, they have different parking spots for different size vehicles. So the next type of parking spot we have is for a car. Now a car happens to be about 8 times the size of a motorbike, and it has 8 bits. So it can store 8 ones. Now, what value is that? So if I switch back to the other screen, if we talk about a byte, I'm saying that the value it can store is between 0 and 255. It cannot be a negative. And I'm just going to bring up my calculator. So I'm on Windows. This is the standard calculator that you have. Not much use for what we're about to do. But if you click here, you can turn it into a programmer's calculator. Now it's got a use. Now what we're going to do, think back to our car park. 8 bits. So the highest number we could store in here would be if all of these had a value of 1. Let's go back to our calculator and let's do it. So we're going to type in binary 1, 2, 3, 4, 5, 6, 7, 8, and you see the decimal value going up until 8 bits gives us a value in decimal of 255. And that is why the value of a byte goes from 0 to 255. Now, the data type that we have been using in our previous examples, we've used it for our variable Q and our variable W. We use the type integer. And an integer can go from 32,768 minus to 32,767 positive. Let's bring the calculator up. Let's start to add some more bits, another 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. What do we get? 65,535. What happened? That's half. Now the reason is, if you remember when we looked at our byte, we said it can go from 0 to 255. With an integer, it can go from minus 32,768 to plus 32,767. Now, if you took all the steps between those numbers, you would finish up with a value of 65,535. And just as we could have our my byte didn't have a negative, can't go negative, there is a version of an integer called an unsigned integer. It cannot be negative, and it goes from 0 to 65,535. So instead of starting sort of halfway, you can go the full range, but you cannot go negative. Going back to our digital car park, I now have my lorry parking spot. That's twice the length of a car and caravan. What do I store in there? I store my longs. Let's bring our calculator back in. Got to add 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We see a number there, 4,294,000,000, etc., etc. if we go down to look at our value of a long, it's half of that negative to half of that positive, or what we call an unsigned long, goes from 0 to the whole number as a positive. Now, it's something that you'll need to learn at some point, the difference between signed and unsigned variables. When a variable is unsigned, it can only be a positive value. Now, in most of the early examples we will use, and even when we start to build the robot car, if you're going to follow that project, we will use an unsigned long when we are measuring time using the millis function, and that's about the only time we will use it. I don't tend to use an unsigned integer. I don't really have a use for that most of the time. I prefer to use a normal integer or a normal long. It just makes it a little bit easier with mathematics, especially if you suddenly go negative by accident. If your parking space can take that, then you're not going to have a problem. So let's go back to our parking spaces and have a little bit more of a think about what's going on here. So here we are back in the digital car park, and the first item that we're going to look at, just quickly switching back to the other screen, we're going to look at a byte. Value of 0 to 255. Switch back. I've changed the number in here, so it's all ones, so that is 255. If you remember on our calculator, wherever it's gone, there it is. I'll bring that in. 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. 8 bits, 255. Let's move that one out. Okay, so that's our digital car park. What happens if the number goes over? Now, where I live, when I go to my supermarket, there's all these signs, and when I go into town, council car park, you must park within the lines. If you park outside of the lines, you will get a ticket. Now, here we are in our numeric variable digital car park, and we have a car park attendant. And if we go outside the limits, let's say we park over the line, our number is too big, the car park attendant doesn't give us a ticket. Oh no. In the digital car park, they cut the front of their car off. That's right. Anything over the line gets chopped off. They're barbaric in this car park. Now, that means that if our number overflows, what number would come after all of these ones? Well, I'll just change this. The next number would be, hang on, bring my typing up here. I'll put a 1 in. So if I went 1 digit higher than this, let's bring our calculator up. We go plus 1 equals, there we go, everything else goes to 0. So let's put 8 zip. Sorry about this. This program really isn't designed to do this, but it was the only one I could find to do it. 1, 2, 3, 4, 5, 6, 7, 8. So that's the value that we would finish up with. But what happens is the digital car park attendant says, hey, your 1 is over the line. I'm going to cut that off your car. What number are we now left with? 0. So if we go back now to our IDE, what I've tried to do is create an example of how that actually works. So just looking back to my variables, I've created a variable called my byte. It can have a value between 0 and 255. If we now come down here, I've also got, just for your information, good old integer q is back in town. So a standard for loop for q equals 0, q is smaller than 300. Why have I gone to 300? Well, because 300 is a bit higher than 255, and we're going to see what happens. So what we're going to do is we're going to go through the loop, and as it goes through the loop, it's going to increase in value, and as it increases in value, we will see the value of q will be serial printed. The decimal value of my byte is going to be printed, and then what I've done is we're also going to print my byte, but if you'll notice this time it's got a comma and then bin. Stands for binary. And what we're going to do is we're going to print it out, the binary number, so we can actually watch the binary numbers increase. So let's compile our code. As usual, it takes some time. Bring up the serial monitor. There we go. It's flashing through my code. There we go. Oops. Click the wrong button there. Let's let it keep going. 190 yard. There we go. Go right up to the top and we'll see what happened. So we started with 0. Value of q was 0, value of my byte was 0, and the binary value for that is 0. We added 1, the binary value is 1. The binary for 2 is 10, 3, 1, 1. And so we're watching now the binary values increase. And it increases and it increases, and we can see the number growing and growing and growing. Now we're using, what, 7 bits are being filled. Now we've got to 8 bits. The number's increasing again until suddenly we get to 255, and at 255 it's all full of ones. The next number is 0. So when q gets to 256, my byte equals 0, and it literally starts to count up again. And that's because, going back to the digital car park, we filled up with ones. We put our 1 that crossed the line, and the digital car parking attendant came along and chopped the front off our car. Bad news for us. Now, I've done a similar example with the unsigned integer, just so that we can go back. Just sort this code out. So I just noticed a slight error there. So we're going to comment this one out. Again, this code will be available to download at the end. So don't worry if you don't grasp it all in one go. I'm going to uncomment this bit of code now. So this time, instead of waiting for it to count up to 65,600, I thought that might be a little bit of a boring video watching that. What we're going to do is we're going to use a variable. This time we're going to use a long. Now the reason I have to use a long is that I want to show an example where I go higher than the limit for my unsigned integer. So I couldn't use an integer because I can't count high enough. So I'm going to use a long, and we're going to start off with my unsigned integer is going to have a value of 65,449. And you'll see the two lines of code will all line up in a second, and hopefully it'll all make sense. So I'm going to close the serial windows monitor so that when we open this, it all starts off fresh. There we are, it's uploaded. Let's start it. Off it goes. And there we see it. So once again, we see the binary number increasing until we get the full length of our car parking slot is full. Just like before, this time our 1 is here. The digital car park attendant has chopped the 1 off, and like here, it's left a row of zeros. And when we go back to our code, we see we go from this value of 65,535, we drop straight back to 0. So I hope that explains to you a little bit about what happens when your number gets too high. Again, you don't need to understand all the details in this, but you just need to get a little bit of a picture of what's going on. Now, you might say to yourself, if I'm going to have the risk of numbers overflowing all the time, why don't I just use the biggest number type possible? Why not just use the variable type long all the time? And at first you would think, well, that makes perfect sense. But what I'm going to do now is try and give you a slight explanation of why that is not a good idea. Now, talk about using a program for the wrong purpose. This is a program called Fritzing, which is designed to show you how to design circuits, but it was the only way that I could get myself a nice visual representation of why it's important that we don't use the wrong variable type. Let's go back to our digital car park. And the first one we're going to look at is the byte. So back to our new screen, and a byte is represented in this case by my 8 LEDs. These are the symbol for an LED, and below them we have a symbol for a switch. Now I want you to imagine that our number is changing. If you remember when we saw the code increase the binary value, if you like, the numbers, if this is on, it's a 1, if it's off, it's a 0. So if I wanted to set this number, I've got to press 8 different light switches to set this number to the right value. And I just want you to think about that for a moment, because that's what's basically happening in the depths of your Arduino. When you have a number that changes, it's basically inside the Arduino, it's running around as fast as possible, turning all the lights on and off. Now, if we go back to our digital car park, we now have 2 bytes. It's our car and caravan. Going back, we now have the car and the caravan. So we have the original 8 bytes where we've got to turn on and off 8 switches, and now we've got a further 8 switches to turn on and off. So if you can imagine from the Arduino's point of view, and this isn't an exact sort of calculation, but realistically it has to do twice as much work to save and load up a byte as it has to do for an integer. So if you've got 2 bytes, you've got twice as many switches to do. If we were using our 4 bytes, our long, we'd have twice as many buttons. But to be honest, I ran out of spots to put LEDs on, and there's other more exciting things in life to do. But the idea then is, for using a long, twice as many buttons would have to be pressed. So one of the important things about using the right variable is it's not just the amount of, if you like, the memory space, because again, twice as much space is required to store a byte as 2 bytes. Pretty obvious. So if we use a massive data type like a long, for every byte of information, we would actually be storing 4 bytes, 3 of which would just be full of the value 0. So this is why we have to be careful with how we use our data types. Now I'm just going to try and give you an example, another example of why this is important. So the picture you see in front of you is my old motorbike. I miss my bike. And as you can see, I was having a wonderful time. I was actually touring Norway at the time. Now this motorbike was 1100cc and it was pretty quick with me on it and my luggage. Now if we think back to our sort of digital example, this is 1 bit. It's moving pretty quick. Now if you imagine 1 bit, we're turning this one switch on and off. Now I've got another picture here. This is my friend's pickup, or his old pickup. Now as you can see, it's a lot bigger. Let's think of this as a byte. It's 8 bits. In fact, looking at the size of this pickup, my goodness, it's almost big enough to be an integer. It's that big. But if you can imagine, this pickup holds a lot more information, but to move at the same speed as my lightweight motorbike, it requires a huge engine to do it. Now the problem that we have with our Arduino is we only have one size engine. If our numbers get bigger, the Arduino doesn't get more powerful, it has the same size engine. So what tends to happen is, as the load gets bigger, we finish up with my motorbike engine stuck inside the pickup. Now if you can imagine, this thing may be able to hold a huge amount of stuff, but if it's powered by my motorbike engine, it's not going to go very fast. And that's what I'm trying to get over to you when we think about our switch system, that we can have all of that information there. We can store all the information, but if we're storing more than we need, our poor little engine is having to pull around huge amounts of weight, and it's going to struggle under the load. You know, there are a limit. You know, if I went out with my old motorbike, with a bit of luck I could get it to pull a caravan. I don't think I could get it to pull a truck. It will blow up under the load. So it's a case of, if we keep using variables that are much bigger than they need to be, then we will slow our Arduino down. Because if you think about it, the only way that this tiny engine that we've put in our pickup is going to work, if that's my motorbike engine in that huge pickup, it'll make the pickup go, but it's only going to be doing 20 miles an hour. He's not going to get any faster than that. And this is why we need to be so careful with our data types, because the bigger the data type we use, the more information is going to have to be stored. The more, if you like, switches, as we saw, to store the data have got to be turned on and off. When we do a calculation, the more switches that have got to be pressed to set the correct number. It all becomes a bigger and bigger load. And that's why having the correct data type is so important. Now, in the sample code, I have actually added a couple of other examples for you to take a look at. And these ones are to do with an integer. Now we've said with an integer it has a value of 32,768 to 32,767 positive, and this example will show you what happens when you exceed it. So if we subtract 1 when we're at the lowest number, what's going to happen? Well, it's going to overflow, and it'll actually come out the other end, if you like. So it'll suddenly go from minus 32,768 to positive 32,767. The explanation is in the code, and you can run that afterwards. But I just want to finish by just giving you an idea of how we choose the right variable. And it's in the bottom here. I hope this is clear enough to see. Let's see if I can just bring that up a little bit bigger. Yeah, that'll do. Okay, choosing a variable. Now, when we're using a value of q in a for loop, we know what the start value is and we know what the end value is. So it's very easy to say, you know, if we're only going up to 300, just use an integer. And to be honest, for most of the time when you're using a for loop, an integer is the ideal number. Where things start to get interesting is when you start to deal with time, or when something is increasing for a long period of time. If you remember in our original control structure, when we were looking at if, we were just incrementing q, and if we'd left it, q could have got to some crazy number. Now, of course, if q had got to 32,767, it would have suddenly swapped over and it would have become minus 32,768 because it would have overrun. So these here are some things to give you some ideas of number sizes. So how many seconds are there in a minute? Well, obviously there's 60. 60 would fit in a byte. So if we had a program that was just counting seconds, providing we only ran it for 1 minute, we would fit that information in a byte. If we ran it for an hour, 60 times 60 equals 3,600. That now becomes an integer. How many seconds in a day? 60 by 60 by 24, 86,400. If you notice, it's in excess of what an integer can take. It's even in excess of what an unsigned integer can take. It requires a long. How many seconds in a year? You're still inside the ability of a long. Now, the problem is with computers and with Arduinos, they count very, very fast. And you'll see in our later examples, when we're dealing with time, and even when we've used the delay, we're talking in milliseconds. So everything is multiplied by 1,000. So all of a sudden, how many milliseconds in a second? 1,000. How many milliseconds in a minute? 60,000. You're already at a long. How many milliseconds in an hour? 3,600,000. Definitely a long. How many milliseconds in a day? 86,400,000. Ooh. Now we're starting to get to some very, very big numbers. And something for you to think about, how many milliseconds in a year? There's 31 billion. Okay? 31 billion is bigger than an unsigned long. Now you need to keep that in mind if ever you're writing a program that you're thinking, you know what, I'm going to keep track of something for a year. If you're not careful, you will run out of number. You'll start overflowing your parking space. Now with millis, when you're looking at milliseconds, you will actually reach the end of an unsigned long in about 50 days. So if you want to go for longer than 50 days, you've got to really start to think about what is going on. And again, we're not going to worry about that in our examples now, and you don't really have to panic about storing that information away in your head, but it's just something for you to understand why these values are so important. Now, of course, we've talked about milliseconds, 1000 milliseconds in a second. The Arduino can also deal with microseconds, 1 million microseconds per second. With an unsigned long, it'll run out of space in 70 minutes. That's why we don't use microseconds very often, because we'll literally run out of space almost before we've started. Now, this may have been a bit of a confusing lesson, but the main thing I want you to understand from this is this little bit at the top that I've put in, that there are various different data types, and there are different occasions when we would want to use those different data types depending on the maximum and the minimum value that we will put in that data type. One of the reasons that an unsigned long works well with time is, of course, if we're using millis, it never goes negative. So you're not suddenly going to get a number that's going below 0. Time is always going in a forwards direction. It's always going to be plus. But within our code, as we saw even when we were doing our for loops, we can have values that become negative, and so where possible, use the integer value int or the normal long. There will be occasions when you will use a byte, and there are occasions when we will use a Boolean, but the main two that we will be using, or the main three, will be the integer. Occasionally we will use long, and when we're dealing with time we will use the unsigned long. When we progress into much later lessons, we'll start to use the byte and the Boolean a little bit more, but that's for the future. I hope this lesson's been informative. I realise it's a lot to take in, and I hope I've tried to put it over in a way that makes sense. Keep in mind that digital car park, if you overflow your value, it will chop the end of your vehicle off and your number will go back to 0. And just bear in mind that the larger the variable type that you are using, the more the Arduino struggles to press all those on and off switches to get everything set correctly. Again, we don't have to panic about it too much, because most of the things that we are working on are not timing critical. But if you start to get programs where they're running very, very fast, you really don't want to be messing around with numbers, variables that are bigger than they have to be. So let's just go back to what we've done. So in lesson 6 we've looked at bits, bytes, integers, longs. If you remember, signed and unsigned. Signed means they can be minus or plus. Unsigned meant the value can only be a positive one. I hope that's all been useful to you. As I say, it has been a lot to take in, and might be worth watching it twice. And don't forget, look in the Arduino reference. There's loads of information there, and it's always there whenever you need it. Never feel ashamed to go back to the reference. We all do it. So bye for now, and as usual, if you enjoyed it, if you want to press the like and subscribe buttons, please do. But thanks for watching.